Garriott. We are pleased to announce our bridge for the Garriott Design Challenge.
Our bridge was designed based off the Paramus bridge that was built in Scotland, England. This bridge was built to replace the Tay River Bridge, which came down in a horrifying disaster in high winds in 1874.
Our bridge that we designed for the Garriott Design Challenge was able to withstand high winds and a simulated earthquake. It's important for the bridge to be flexible during an earthquake, as this is comparable to a shuttle docking on the International Space Station. However, there is a lack of cross bracing in the center. As a result, the bridge had a moderate sag in the center when weighted down.
Cross brake would be helpful there in improvement.
For the Garriott Engineering Design Challenge, we had to build a bridge to withstand the forces of nature. The forces of nature that it had to withstand were winds, earthquakes, and the weight of cars passing over the bridge. We used a fan to simulate wind going over the bridge. We shook the table that the bridge was on to simulate an earthquake. Then we used magnets in a bowl, putting weight on the bridge to simulate cars passing over the bridge.
This bridge was built for the Garriott Engineering Design Challenge. The forces of gravity, wind, earthquake vibrations, and load did not affect the structure of our bridge. Our bridge was built with a certain design which caused it to withstand forces of nature. We used trusses to even out the pressure that was created. When we placed those trusses strategically to counteract forces on different sections of the bridge. The towers built supported the bridge, which kept it from collapsing. There are many similarities between our bridge and the International Space Station. One of them is the flexibility. It is important to have flexibility when within your bridge so the forces do not cause it to collapse. We based our project off the International Space Station and it succeeded.
If we were to redesign the bridge, we would probably make it more flexible and add trusses in better locations than they are now.
For the Garriott Engineering Design Challenge, we had to design a structure that would withstand the elements on Earth, such as wind, weight, water, weathering, and temperature fluctuation.
With all these elements being pointed here, as with cars, increasing weight on the bridge, it actually forms like a sag that holds the cars. The road is flexible, that it holds it against wind and pressure. So, like if it's too stiff, it'll be able to break pretty easily. So, it needed flexibility. And it also helps with the pressure of the cars, like the weight pulling it down.
Well, what does it have in common with the space station? Well, bridges need flexibility to ensure contracting and retracting due to the weather. The space station also needs to be able to withstand the elements of space, such as space junk, gravity, as it is falling towards the Earth all the time, and the constant orbiting of the Earth, which causes it to endure freezing and warm temperatures when faces or is on the other side of the Earth away from the sun.